Good afternoon, class. We are looking at section 5.4, right triangle trigonometry. Here's the second part. We covered the first part. We looked at a couple of application problems. And now we will continue looking at more applications. Navigation and surveying. A bearing is used to represent the direction of one point relative to another point. Method 1. The direction of bearing of a point is the number of degrees in the angle measured in a clockwise direction from the north. So this is north, south, east, west. So clockwise from the north, which is the vertical line, to the line joining center of the compass with the point. So just as an example, this one, you would just say 30 degrees, that's all. Or P1, just as an example. Method 2. Direction or bearing of a point O to a point P equals, so these are the points. The acute angle theta has to be between 0 and 90 degrees. Between the ray OP and the vertical line through O, either the north or the south line. Again, as an example here, we would say north, and this side is east, so we would say north 30 degrees east, just as an example. So let's look at method 2 first, and as I mentioned, the first one, P1, is north, you're looking at north, 30 degrees east. Now P2 is closer to the south, so we start with either north or south first. So this is south, and this is west. So southwest, in between is 50. So we say south, 50 west. South, 50 degrees west. P sub 3 is closer to north from this side. So this is north, this is west. In between is 70 degrees. So north, 70 degrees west. P4, closer to south than north, okay? And this angle is 20 degrees. So south, and this is east. South, and this is east. So what's in between? 20 degrees south, 20 degrees east. South, 20 degrees east. So that's method 2. So method 2, you go either with north or south. Which one? The one that is closest. And the angle must be between 0 and 90 degrees. Whereas method 1 basically looks at the positive side of north. So obviously the first one is 30. So all you have to do is say 30 degrees. So those are, by the way, what I just wrote for you. North 30 degrees east, south 50 degrees west, north 70 degrees west, and as I mentioned, this one south 20 degrees east. Now let's go with method 1, and this one is just 30 degrees. But what about P2? P2. You start from here and you go to P2. This angle, that's all you're saying, this angle. So from the positive side, clockwise, as you can see here is 180 degrees, 50 and 180, they add up to 230. P3. P3. This angle. That's all you're saying, this angle, because you always compare it to the north, okay? This one. That's all. So what is this angle? So up to here is 270 degrees. And because this is 70, this must be 20 degrees. Plus, this is 70 degrees. This must be 20 degrees, right? So 20 degrees and 270, they add up to 290 degrees. P4, the angle would go from here to here, this angle, that's all. Well, how do you measure that? Because this whole thing up to here would be 180, subtract 20, and you get 160 degrees. So it's very straightforward, everybody. So two methods. An airplane takes off from a runway which has the bearing of north 20 degrees east. It flies for 1 mile and then the pilot requests permission from the control tower and turns 90 degrees heading towards the northwest. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the airplane? So an airplane takes off from a runway with the bearing of north 20 degrees east. So let's just, so north 20 degrees east. So north 20 degrees east. It flies for 1 mile. And then the pilot requests permission from the control tower and turns 90 degrees heading towards northwest, so this way. And this angle is 90 degrees. After the plane goes for 2 miles in this direction, what bearing should the control tower use to locate the aircraft? So here's the runway, 20 degrees, 1 mile, 90-degree turn, 2 miles, and now we are here, and this angle, let's call it alpha. If this angle is alpha, the bearing is north, alpha, west. Okay, so O to Q, north, alpha, west. And what is alpha? This total angle is called theta. And we know this is 20 degrees. If we subtract 20 degrees from theta, we have the answer. So let's find theta. To find theta, we look at this right triangle. Tan of this angle theta is the opposite over the adjacent. PQ over OP, 2 over 1 or simply 2. So what is theta? Tan inverse of 2. And you put it into a calculator. So when you put it into a calculator, it results in 63.4 degrees. So theta is 63.4 degrees. What we want is alpha, which is 63.4 degrees minus 20 degrees. Makes it 43.4 degrees. So we go back to here and replace the alpha, and we say the bearing is north, 43.4 degrees west. Pretty straightforward. A security camera is mounted on a wall 9 feet above the floor. What angle of depression? So 9 feet. What angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 12 feet from the wall? So here's 9 feet. Here's the camera, everybody. And we need to find this angle. We know this distance is 12 feet. It has to be directed to a spot 6 feet above the floor. So this distance is 6. If this is 6, this must be 3. So first, let's make sure we understand the setting and it makes sense to us. So tan of this angle is the opposite, which is 3 over the adjacent, which is 12 feet. So 3 over 12, or 1/4. So A is a tan inverse of that. Putting it into a calculator results in the answer, and you can say about 14 degrees, depends how they want it. 14.04 or 14 degrees, depending on how many decimals they ask. Okay, everybody? A straight trail with an inclination of 17 degrees leads a cottage at an elevation of 9,000 feet to a mountain peak at an elevation of 11,200 feet. Find the length of the trail. So here's the trail. This is X that we are looking for. This is the angle 17 degrees. It's at an elevation of 9 1,000 feet. And this entire distance, we call it AB, is 11,200 feet. So what are we looking for? We are looking to find this. And then that will help us find X. So what is this equal to? The difference of these two numbers, 2,200 feet. Now that is 2,200 feet. Sine of 17 degrees is 2,200 feet over X. This is the opposite over the hypotenuse. Sine of 17 degrees is 2,200 because we found this to be 2,200. Divided by X. Therefore, X is 2,200 divided by sine 17. Put it into a calculator, you get that. So let's just write that step. So X is 2,200 over sine of 17 degrees. Okay, everyone? So that gives you the answer. Find the inclination or grade of the trail. We are interested in finding this. That's the idea. Okay. We want to find this angle, and clearly we can use sine because sine of B is the opposite, which is 3,100 over the hypotenuse, which is 14,100. 31 over 141. It's not a common arc. You have to put it into a calculator. So B is sine inverse of this number. Put it into a calculator. If you go with one decimal, 12.7, because next to this year, again, the number of decimals, normally they ask you. A visitor at the top of the gateway arc, which is 630 feet in St. Louis, Missouri, observes a boat moored on Illinois side of the Mississippi River, 2,070 feet directly across from the arc. So this one from the base of the arc has the distance of 2,070 feet. She also observes a boat moored on the Missouri side directly across from the first boat. So directly from it is this boat. Given that B, the angle B is cotangent inverse of 67 over 55. Please understand, you can put this into a calculator, it gives you an angle. This is an exact answer. When you put an angle, it's an approximation. And of course, cotangent inverse, you have to use either tangent or cosine. Because this is positive, you can use tangent, the reciprocal of this number. Otherwise, you have to use cosine. In any event, estimate the width of the Mississippi River at the St. Louis riverfront. So what are we looking for? This distance, we're going to call it x. The distance that we are looking for, the width, is 2070 minus x. So first, understanding what we are looking for. So now we are going through the process of finding x, subtracting it from 2007. And because this is 630, okay, if we could find a, the value of a, the angle a, this angle, we can find x, and then we are in good shape. So this is a, this is b. So this is a plus b. Tan of a plus b is the opposite 2070 over the adjacent 630. And that we can calculate. The idea is very simple. We can calculate this angle, and then this angle is given. Subtract from it. That's all there is to it. So 2070, so a plus b is the tan inverse of this number. You can drop the 0, put it into a calculator, and that gives you the answer. We want a. What is a? This minus that. Please understand, we want a, and a is this minus b, and b is this one. So I hope everybody's clear as to what's going on here. So we're practically done, because all we have to do is a calculator here. This one, you put it into a calculator. I dropped a 0. Okay, everybody. In fact, they're both divisible by 9 also, because 2 plus 0 plus 7 is 9, 6 plus 3. You can divide both of them. But anyways, plug it in and you get this number. We are going to plug this in. Notice what I'm going to do. Instead of 67 over 55, I'm going to use 55 over 67 with tan inverse. Why? The calculators don't have cotangent inverse. Please pay attention to what happened. I'm going to write the reciprocal of this number, 55 over 67, and I use tan inverse. Because it's in the first quadrant, you can do that. Remember, tangent goes from negative power to power 2, but cotangent goes from 0 to pi. I'm talking about the inverse function. So if it happened to be negative, you can't do that in any event. So the difference between these two numbers. So you subtract this from there, you put it into a calculator, and it gives you 33.6. If we stop here, 33.69 degrees. So that's A. We are in good shape. Tan of A is the opposite x over the adjacent 630. Therefore, x is the product of these two. It's the cross product, everybody. This is equal to that. So 630 tan A, and it's 420 feet. Again, tan of this. Okay, you put it into a calculator, gives you 420 feet. Remember, all of this is approximation, okay? So that's why perhaps going with the whole number is fine. So now subtract this from 2070. $1,650 is the answer. A quick recap, angle B is given. We find the sum of A plus B. using the fact that we have two sides. Again, angle B was given. Subtracted from the sum, you get A, and from A, you can get 2x. The Gibbs Hill Lighthouse, Southampton, Bermuda, in operation since 1864, stands 117 feet high on a hill, 245 feet high. This is the sum of these two numbers. So its beam of light is 362 feet above sea level if we add these two numbers. A brochure states that the light itself can be seen on a horizontal about 26 miles distant. Verify the accuracy of this statement. Earth's radius is 3,960 miles roughly, and 1 mile is 5,280 feet. So let's see what we do. The idea is to find the distance S, which is equal to r theta. We have the r. We need to find the theta. And to find the theta, you can go, for example, cosine is the adjacent, which is this number, over the hypotenuse, which is the sum of these two numbers. So cosine theta is adjacent over the hypotenuse. And therefore, cosine theta, the adjacent to theta is this number, 3960. And the hypotenuse is the sum of these two numbers. And I'm going to just write it as sum of those two. Now, this one is 362 feet. This one is 3,960 miles. So I'm going to divide it by 5280. This is the reason. Okay. We are dividing it by 5280 because it's a one mile is 5,280. And so it's almost one, but it's not one. It's almost one. And it makes a difference. You have to figure out the answer. So you want the theta, and theta is cosine inverse of this number. If you put it into a calculator, theta is cosine inverse of this number. It gives you a very small angle, 0.33715, about 20 degrees, 20.23 degrees. Remember, S equals R theta. We found theta, but theta has to be in radians. So multiplied by pi over 180. So it's 0.00588 radians. And S equals R theta, multiply this number by this number to find S equals R theta. And the product is about 23.3 miles. What did they say? 26 miles. It's an overstated statement. Way too much. Find the angle of elevation of the sun if at 10 a.m. on April 26, 2000, a building 300 feet high cast a shadow of 50 feet long. Meaning, here's the sun and here's the building. It creates this shadow, and this angle is the angle of elevation, everybody. And that's easy to calculate because tan of this angle is the opposite over the adjacent, 300 over 50, which makes it 6. And so if tan A is 6, A must be tan inverse of 6. Using a calculator, we get 80.5 degrees or so. A laser beam is to be directed through a small hole in the center of a circle of radius 10 feet. So here's the circle of 10 feet in the center. There is a small hole. The origin of the beam is 35 feet from the circle. So we have this distance of 35 feet. At what angle of elevation should the beam be aimed to ensure that it goes through the hole? So we have the laser, and here's the angle of elevation. We have this distance, which is 35 feet. We have this distance, which is 10 feet, because that's the radius, right, of a circle. So that's the angle. Tan of theta is the opposite, 10 over the adjacent 35. So theta is the tan inverse of this number. Of course, we can simplify it by a factor of 5. It doesn't matter. You are putting into account. So tan inverse of 10 over 35 or tan inverse of 2 over 7. And that gives us 15.9 degrees. Finding the bearing of a ship. A ship leaves the port of Miami with a bearing of south 80 degrees east. So here's south. Make 80 degrees because it is on this side going that way. That's the idea. And a speed of 15 knots, 1 knot is about 1.51 miles per hour. After 1 hour, the ship turns 90 degrees towards the south. So it's going this way and then moves that way. After 2 hours maintaining the same speed, what is the bearing to the ship from port? So let's revisit this quickly as follows. So it's going to go this way. That's the 80 degrees. And then it makes a 90-degree turn. This is going for 1 hour. This is going for 2 hours. Okay, 1, 2. And at 2 hours later, we are at point B, and we want to know the bearing now for point B, which is simply south, whatever this angle is, B, and this angle, let's call it theta, so would be south, theta B. Which means if we find theta, we are in good shape. Now, notice the angle AMB, AMB. If we find it, we can subtract it from AD to obtain theta. In other words, theta is 80 degrees minus this angle. This one. Okay. That's A and B. So all you have to do, look at this triangle, try to find this angle. That's all we are looking for. So what is the tangent of this is the opposite, AB over the adjacent AM. So we want this tangent. The opposite is AB over AM. AB after 2 hours, remember the speed is 15 knots. So 15 times 2. In this case, 15 times 1. You can keep the units the same because they're both knots. That's fine. And so the answer is 2. I hope everybody's clear. This is after 1 hour, 1 times 15, D equals RT. This is after 2 hours, 2 times 15. So if this angle, its tangent is 2, then tan inverse of 2 is the answer, which gives us 63.4 degrees. So all we have to do is subtract this from 80 degrees. That gives us 16.6 degrees. And so the bearing is south theta, which is 16.6 degrees east. Example 17. A camera is mounted on a tripod 4 feet high at a distance of 10 feet from George, who is 6 feet tall. Camera lens has angles of depression and elevation of 20 degrees. This way is 20, this way is 20. Will George's feet and head be seen by the lens? If not, how far back will the camera need to be moved to include George's feet and head? Let's ignore the 10 and let's say we need X amount. So we are going to calculate the X amount. We are ignoring the 10 and we see if 10 works or not. So if we look at this triangle, the height is 4 feet. So this side is 4 feet. This distance we are using X. So this is 4 feet. This is X feet. Because George is 6 feet, then from here up is 2 feet. And if we cover this one, which is 4 feet, for sure it will cover this one because 4 is larger than 2. So this beam goes way over his head if this works. So that's why we have to go with this. The reason we have to go with this, because this is given, this is fixed. So tan of 20 degrees is the opposite, which is 4 over the adjacent, which is missing x. 4 over x. The concept of a cross product says we can interchange these two. X is 4 over tan 20. By the way, what I just explained, note, using 4 feet guarantees the foot is covered. Consequently, the head is covered too. And even more since 4 feet is larger than 2 feet. So if we cover the foot, and this is 4 feet, for sure, this is the same 20 degrees, right? So whatever this covers, this will cover too. And according to this, if we go with 4, it covers up to 4. So definitely the head will be covered. All right, so with that being the case, x is 4 over 10 tan 20, as I mentioned, comes from a cross product. So you can interchange those, because x times this is 1 times 4, and 4 divided by tan 20. You put it into a calculator now. When you put it into a calculator, you get 10.99, almost 11 feet. So the distance was 10 feet. That's not good. No, the camera has to move back by almost a foot.